Okay, to start this video, we are going to finish off with our 2.3 day 1 notes. And we did adding and subtracting in class. Now we're going to talk about multiplying. In order to multiply a polynomial times another polynomial, we have to either distribute or FOIL. So I'm going to go ahead and show you. I think we'll go ahead and start it with problem number 5. If I have 4y squared times y squared plus 3, this is a monomial, one term, times a binomial. So in this case, whenever you have a monomial times anything, you can just distribute that monomial into the binomial, here and here. And the leading coefficient is 1 if there isn't one written. And so now I have 4 times 1 is 4, and I have y squared times y squared is y to the 4th. Anytime you're multiplying variables, you add the exponents. And now I have 4 times 3 is plus 12, and y squared times nothing is just no y's, is just y squared. So that is how you multiply that one. Now if I have a problem like x minus 3 times 3x plus 4, this is a binomial times a binomial. In this case, we have to FOIL. If you don't recall what FOIL stands for, back from Algebra 1, it's first, outside, inside, last. So here's the first term, and here's the first term of this binomial. And then we have the outsides are the terms on the outside, and then the inside are the terms on the inside, and the last are the last in each binomial. So first is x times 3x is 3x squared. Outside is x times 4 is plus 4x. Inside, minus 3 times 3x is minus 9x. And last, negative 3 times 4 is negative 12. And now I just need to clean this up. 4x minus 9x is negative 5x minus 12. Okay? So if you have a longer, like if you have a binomial, 2x plus 1, times a trinomial, then what you do is multiply the 2x times each term, and you'll multiply the plus 1 times each term. And that's really what you do anytime you're multiplying a binomial times anything larger, or even a trinomial times a trinomial. So we have 2x times 3x is 6x cubed, 3x squared, excuse me. 2x times negative x is negative 2x squared, and 2x times 3 is plus 6x. Now I've got 1 times 3x is plus 3x squared, and 1 times anything just keeps everything the same. So now I need to clean it up. 6x cubed, got it. Minus 2x squared plus 3x squared is plus x squared. I've got 6x minus x is plus 5x, and then a plus 3 hanging out at the end. Okay, take a moment, pause that if you need to. Make sure you get that copied down. The one that I would like you to try is y minus 5 squared. And remember, anytime you're squaring something, you need to write it out times itself twice. So go ahead and do that, and that's one of the problems that I will check. Okay, so now we're going to move into 2.3 day 2, factoring, GCFs, and by grouping. Okay, so factoring, first of all, GCF stands for greatest common factor. So you divide your numbers and subtract your exponents. And that will make more sense in just a minute. Divide your numbers and subtract your exponents. So for example, 2x squared plus 4x. I need to look at 2 and 4. What's the greatest number that divides evenly into a 2 and a 4? And that answer is 2. And how many x's go into 2 x's and 1 x? How many could I take out of each pile? And that's 1. So it leaves me with 1 here and none here. So I can take a 1x out. And so what does it leave us with? Well, 2 divided by 2 is 1, and 2 minus 1 is 1. So I have 1x, and 4 divided by 2 is 2, and x to the first divided by x to the first cancels. And so you're left with 2x times x plus 2. And if you distribute this back in, you will get the original problem back. Okay? Hopefully this isn't all new, but if it is, we'll do a couple. Go ahead and pause that, get the problem written down, because what we're going to look at first is what number goes into 4, 6, and 8. And the largest number that does that is 2. And how many can I pull out of 3, 2, and 1? Well, the largest number I can pull out of all three of those is 1. Now you see what's left. 4 divided by 2 is 2. I'll do my numbers first. 6 divided by 2 is 3. And negative 8 divided by 2 is negative 4. And now I have 3 minus 1. That was where we divided our numbers. Now we're subtracting our exponents. 3 minus 1 is 2. 2 minus 1 is 1. And 1 minus 1 is 0. So there you go. That's factored. P squared plus RP. Well, what's the same in each term? Remember, the terms are broken up over the plus sign. I have 2 P's here and an R and a P here. So I have a P in each of those. And if I pull a P out of P squared, I have 1 P left. And if I pull a P out of RP, I just have R. So there you go. So there's another one for you to try. Go ahead and pause it so you can do that. All of the problems I give you to try are what I'm going to be checking to determine if you did the notes correctly. So our difference of squares is our next method. So it comes from an a squared minus b squared. And that formula looks like a plus b times a minus b. Go ahead and get that written down. Oh, you already counted. Okay, the next problem we're going to look at is x squared minus 4. Now the first thing we need to do is determine if this is a difference of squares. So I've got x squared. Is that something squared? Yes. X squared is x times x. Difference means minus, so I've got that. 4, is that something squared? Yes, 4 equals 2 times 2, or 2 squared. So now that I know A is going to be what is squared here. Well, what is squared in x squared? X. And B squared is 4, so what's B? 2. So I have an A plus B, which is x plus 2, and an x minus 2. And that uses this formula. Once you know that what A and B are, you just plug it in. And the quick way that I remember it is I just say, okay, if it's a difference of squares, which this is, then I just square root the front, square root the back, write it twice, and the signs are one of each. One's positive, one's negative. So let's try that again. 3x squared minus 27. Is this a difference of squares? Well, I have a difference, but 3 is not a square, and neither is 27. But if you recall from our method we just talked about, I can GCF a 3 out. And now I have difference of squares, so my 3 just stays out front. So what I do is I square root the front, which is x, I square root the back, I write it twice, and my signs are one of each. And it doesn't even matter if you put plus or minus plus. Order does not matter. Okay? Number 7, negative 36 minus x squared. So this negative is going to stay out here because I have difference of squares. I've got a difference, and these are both squares. So when I square root this, I've got square root of 36 is 6, so I'm going to write it twice, and the square root of x squared is x. Signs, one of each. So go ahead and get this written down, and I want you to try the next two problems. The hint for this one, what's being squared, x to the 4th, is x squared times x squared. So that's what's being squared there. And then the last one that I want to look at is x squared plus 49. Is this a difference of squares? Well, x squared, yes, I can square root that, and I can square root the 49, but is it a difference? No, this is a plus sign, so it's not a difference, so this is actually prime. Sum of squares don't factor. There's nothing I can do to factor that. That is a sum of squares. So that's where we're going to end today, and we'll pick up next time you see me on grouping. If you have any questions, again, as always, please come in and see me, come in for help. But I will be coming around checking notes, and I'm going to especially check the problems that I have not done. Hope you have a good day.